Okay, we are going to learn to factor the difference of two squares. So our factoring pattern comes from a multiplication pattern that we all know. Remember that if you have to multiply a minus b times a plus b, if you do this by FOIL, you will get the first, the outside, the inside, and the last. Right? Because this is equals to that, we can cancel and we get a squared minus b squared. So a minus b times a plus b is equal to a squared minus b squared. So we can say that a squared minus b squared is a minus b. We're really just rewriting this equation. Okay? In other words, when I have two squares, these are called squares, okay? The decomposition of the factorization of this expression is the product of two binomials, okay? One is a minus b, the other one is a plus b. So I'm going to give you an example. So suppose that we have x squared minus 4. This is a square and this is a square. Okay? Now, let's just talk for a minute. What makes 4 square? 4 is square because 2 to the second is 4. Yes? 9 is square because 9 is 3 to the second. 16 is a square because 16 is 4 to the second. 25 is a square because 25 is 5 to the second. 5 is not a square. 5 is not a square. Yes, 6 is not a square. So if we have a number that's set to the second power gives us that given number, that number then is a square. Okay? So because this is a square and this is a square, the factorization of this binomial is two binomials, the product of two binomials, right? One with a minus, other one with a plus, and then remember that to get 4, 4 is 2 to the second. So I'm going to take that 2 and it's going to be x minus 2, x plus 2. Okay? Let's do another example and let's see if we have, let's take the first example, x squared minus 1. Okay, so if I want to factor x squared minus 1, this is a square, right? This is a square, right? So the factorization will be x minus x plus, right? Think about how you get 1. In other words, what's the square root of 1? The square root of 1 is 1. So it's x minus 1, x plus 1. What about the next problem? The next problem we have t squared minus 9. Okay, this is a square, right? And this is a square. The square root of 9 is 3. So 9 is a square. So the factorization will be t and t minus and plus, and because the square root of 9 is 3, is t minus 3, t plus 3. Okay? Let's go with another one. 36 minus x squared. So, yes, this is a square. Yes, this is a square. This is a square because the square root of 36 is 6. So here we have 6 minus x times 6 plus x. Okay? Remember that a number is a square. If you get the square root of that number and you get yourself a natural number, then that number is a square. Okay? So here we go. 3x squared minus 27. Oh, I'm having a problem because this number right here is not a square. However, I see that the leading coefficient, right, is 3 and 27 is divisible by 3. So what if we factor 3? Yes? And now we're getting to the difference of a square, a binomial that represents the difference of a square, and I can factor that. The square root of 9 is 3, so it will be x minus 3, x plus 3. So this is the factorization of this problem. Okay, let's do a very last example. Problem number 5. Let's say that we have 7a squared minus 112. Okay, so let's look at this. And let's look at this. So what do we have? Okay, this is not a square, correct? So what happens if it's not a square? Well, I'm going to see if there is a common factor with this term right here. If I look, I see that 7 divides, of course, the first coefficient, and 7 divides the second coefficient. If you divide 112 by 7, right, you get 16. So it will be 7e squared minus 16. Okay? 7 it divides 112. If you divide 112 by 7, you get 16. So I now have a difference of squares. Remember, 16 is square, because if I do the square root of 16, I get 4, which is a whole number. So it's going to be a minus 4, a plus 4. Okay? And now I have my complete factorization.